I went to film at the town of Namur, where the director of the project, Jean-Jacques Pirot, has his laboratory. It's a town on the river Meuse, with a nice old centre, which is where the university is. At this point, I didn't understand how the project could end up with a detector to sense gases. I asked Jean-Jacques to pretend my camera was a visitor.
So, Jean-Jacques.
Hi, good morning. Welcome in Namur. Welcome to the university. Let's follow me to the Lise laboratory.
I was surprised at how professionally and how warmly he did it.
Let's go to the Faculty of Science.
His lab specializes in electronic spectroscopy.
So welcome.
It's to do with the analysis of materials and their surfaces at extremely small dimensions.
Here is the laboratory itself, but more important are the persons.
In the lab were
And
Alex
here
and
we
Irina.
have
She was on her
for
first
this
visit
Nano2hybrids
to Jean-Jacques' lab.
Irina, coming from France, formerly from Spain, and then Alex, who is my PhD student.
This project is right at the beginning, just about to begin. What would be success at the end of it in 3 years' time?
Oh, to say it in a few words, it's quite difficult because we have a lot of deliverables to produce, about 40 of them, but the success for the European Commission would be to reach our major goal, which is to design, build, and have operative new gas sensors. This will be based on a new technology, metal nanoclusters dispersed on a carbon nanotube, and this should be a world premiere with sensors of very high sensitivity.
Alex showed me a pot of carbon nanotubes and how he attached a few of them to this extremely fine grid that later he would put into an electron microscope. The nanotubes were suspended in the liquid, and as it evaporated, it left a thin scaffold of nanotubes across the gauze. Then he took them to his vacuum machine, in which he would get a few atoms of metal to grow on them as small clusters. The first step is to expose the nanotubes to whatever it is that a plasma does to them. I wasn't particularly interested in the plasma. I thought they were drawing it to my attention because as a cameraman I'd like the pretty color.
A wire here. It can be either a gold wire, a silver wire. So what metal we want to evaporate on the nanotubes. So it's very simple. So we use this evaporation cell and we put it in this chamber so that we can have the plasma treatment and the evaporation, the metal evaporation in the same chamber. So it's really easy to produce like this the nano2hybrids.
The plasma was switched off and the nanotubes pulled back into the vacuum chamber. The wire then is made red hot. I suppose if we could see them, the metal atoms would be flying around in there like angry bees. Some settling onto the nanotubes stuck onto the little gauze mesh. The next part of the experiment is to look and see what happened. For that, the gauze plus nanotubes plus metal clusters goes into an electron microscope.
Okay, I'm taking the grid, the time grid, where there are the nanotubes. Then I put it on the sample holder that will go on the inside the microscope. That's it.
The magnification is about 100,000 times.
Here in the center. So we have a grid with hole. So the black points that you see on it, it's silver nanoparticles that are on the top of the nanotube.
And what are they?
What are they?
What are these black dots?
It's silver nanoparticles.
I see.
Silver nanoparticles. And you can see that here the scale is 100 nanometer. So this means that maybe the diameter of the nanotubes is something like 20, 30 nanometer. And the nanoparticle, or maybe like 5 nanometer of diameter.
Is this a good result, this one?
Not too good, because we use silver that is not interacting a lot with the nanotubes. So what we will do, we will try to see what happens when we treat the nanotube with an oxygen plasma or with other gases.
I can't see how what happens on a nanotube could be relayed to any kind of instrument that would allow you to know that the gas was there.
Yeah. I don't have a sensor here. I have another kind of sensor which has been designed for, well, this is a biosensor. But the sensor will be about this side, 1 square centimeter, a glass substrate with a silicon layer and a carbon nanotube fitted onto it, and the resistivity or conductivity of the carbon nanotube layer will change depending on gas absorption. So simple electrical measurement will monitor resistivity change, so absorption of gases. So this will be a gas detection unit.
Oh,
tell me what kind of person you are. Are you married? What do your parents do?
I'm a person that don't like to talk too much about him, but my father is a doctor, my mother is a housewife. What I like to travel. This is nice because it's nice to do science when you like to travel, because you travel a lot. I like photography. I like to do sport. We have a football team here in the university, so it's nice we can do.
My father was a teacher in a small village in the very south of Belgium. And my parents were good enough to allow me to go to school, to go to the university, and to choose everything, and they made all what was necessary so that I could go to the university. It's only maybe 6 months before going to the university that I decided I would go to science, and I would go to physics in particular. I was, I think, a very good student, and I could have chosen to go to literature, to art, or to economics, or to law, but science was attracting me. I remember that I read someday a book by Enrico Fermi, on nuclear physics, and I said, that was maybe the year before to go to university, and I said to myself, I will do that. I will study nuclear physics. I studied nuclear physics, but I never worked in nuclear physics. I have been on another way.
What's the attraction of science?
What was the attraction of science? I think this is almost for every physicist, because if you ask to a physicist why he went to study physics, he or she is answering, I would like to understand what is around me. I would like to understand.
Are you married? Do you have children? And how do you as a family occupy your time outside science?
I am married, yes. I have 3 children and 1 daughter and 2 boys. The daughter is now 32 or 33 years old, and she followed my track. She studied astrophysics, and now she is working south of France in the Observatory of Nice. I'm married. My wife has been working in the kindergarten of the university for many years. Now she's working at home. She's enjoying pottery, watercolors, taking care of the garden, etc. And she is extremely patient with me because I go to work very early in the morning, I come back late in the evening, and I'm traveling a lot. Really a lot. So, well, she's very patient. Sometimes something is exploding at home, but my wife is very patient.